So we have already done the differential and matrices. What we have done last time, that we learned how to calculate different weights in portfolio, right? We used Excel to find out that thing. Don't worry, I will share the whiteboard soon. I didn't just did at the moment you are just seeing the shared screen, right? Yeah, from here onward. So we now you know how to give weights, how to find out that what investment we should put in what assets, right? So we did some formulation in Excel. How we find the average, variance, standard deviation, covariance, and correlation matrices in Excel. We did this. We practiced that, especially of returns on any stock. So today, let's find out the concept of probability. What is probability? Most of you have already learned about probability in your some previous courses. If you are taking also statistics, I already taught this concept in statistics course with deep analysis. But in this chapter, in this lecture, we're gonna learn about the basic of probability and its distribution, because it's really important when we are going to analyze any kind of data. So what is probability? What comes in our mind? Some of its key concept we're gonna grab. We will also learn, like the key concept will gonna include like central tendencies, how to measure the central tendencies, how to measure the key points in the distribution. And finally, we will also learn about probability distribution, that what exactly the probability distribution. So it will involve a little bit of mathematics. So I hope that I won't let you feel bored with numbers. So we will try to take like real life examples. So if I ask you simply, what are the chances for you to understand this lesson? Because right now we didn't finish the lesson gonna finish after 2 hours. So right now, before the class, if I ask you that what are the chances that you will understand this lesson, then some of you will say that they will understand. So I'm talking about the probability, right? So some of you will understand, and some of you will say that we will understand 100%. Um, that means completely. This is the perfect scenario, almost impossible, because then it's a fact. Some of you will say probably understood, which means like around 80%. So you are giving yourself a chances, likelihood of occurrence. If complete, then 100%. If less than 80%, and so on. Even some of you will say that they didn't understand, they won't understand at all, which means 0%. So from 100, so it means the probability lies from 100% to 0%, or from 0% to 1. We can also say that the probability lies between 0 and 1. So that's like just for a random example. But all of you are attaching the weight with your outcomes. That is it. It's known as probability. So formally speaking, if I define probability in a single line, I will say that probability is the likelihood. Probability is the likelihood of an outcome or event to occur. So what is your guess if the likelihood is 100%? For example, if you are saying that we will completely understand this lesson, then this means that there is no error. What you expect and what you get as an observation means zero error, zero variation. Similarly, the more the difference, the higher the variation is, the higher the error will be. Now, so far this is how we define probability. Before going forward, you must know different kinds of variable. That is fixed variable and random variable. From the name, it's obvious that what does variable means. You know, variable means anything which can vary. That's variable, right? If something is fixed or constant, that's a constant or fixed number. But like temperature changes over the time, so we call that temperature as a variable, right? So we can say any observation as a variable which changes over the time, over the period of time. And from the word random, it's a random, right? It's not random. I think it's a misspelling. So now it's correct. So typo error, right? So by this name, random, so it's obvious, like you don't have any plan, you just choose it randomly. Then if we have a set of values, let's say I have like a bag. In that bag there are different balls, one, and there are numbers on it, right? And 4, 1, 2, 3, 4, up to 100. And I choose, without looking into the bag, I choose just randomly. So it means all the balls in the bag have equal chances for being selected. That's it. So can I say that within a given set of values and variable that can have any one value from the given set, and there is a chance of occurring that value, then it's known as a random variable. As I told you, the colorful balls in the bag, or let's say we have a deck of a card, can be used to clarify the example. Now I will give you a very simple example. I hope that everybody of you can see me now. Sorry, I have to move like in this way so that later on, that's why my sitting position is a bit odd. So this is like a deck. So here I'm not teaching you how to learn casino, but some tricks with a probability. Now this is known as deck, and there I have cards. So I'm taking out this joker cards. So now I have 52 cards. So there are 52 cards, right? If I put like in the deck or just in my hand, so what is the probability of each card that I pick? So the probability of each card, because there are total 52 cards, so every card has a chance of 1 by 52. That's every single card, including number cards. Remember, there are 10 number cards and 3, if I'm not wrong, 3 picture cards, and 10 number cards with different shapes, with 4 different shapes. There is diamond, heart, club, and spade. I'm not so good in diagram. So if you see, so these are different ones. So what is the probability of single card? That's 1 by 52. So what is the probability of picking 9 of diamond? from this deck is 1 by 52, which is like 0.0000, maybe 0.030 something. You can calculate what is 1 by 52. So that's how we can learn. Then we minimize the probability. What is the probability of picking the picture cards? So total there are how many picture cards? 3, 1 by 52 times 3 times 4, 12 by 52. So that's how we add up the probabilities, and so on, so on. So that's how we can, because now each and every card has equal chances of being selected. I can select this one, I can select the lower one, I can select the upper one, because I don't know, it's just a random selection. So exactly the same way how we did the exactly the same way how we did the marbles or colorful ball example, and so on. You can also, we will later on, we will also learn how to get the probability from a dice, that what number will come. Now, if from a dice, the outcome, possible outcome can be fixed. So there can be fixed possible outcomes, which if I roll a die, I can have. Uh, that means like I can have like 1, 2, 3, 4, 5, or 6. Now you can realize that random variable is not perfectly predictable, because if it's perfectly predictable, that means probability is 100%, which is almost impossible. So we can say a variable having a value from a given set with some chances of occurring, that's a random variable. And it's not perfectly predictable, because nobody can, I will not say it's impossible, but it's also not possible. So if it's perfectly means 1, that it means I'm 100% sure that I can pick 10 of diamond from the deck of the cards, which I can only be sure if all the cards are 10 of diamonds, right, in the deck. So which is not possible. Mostly in economics and finance, we deal with random variables, but sometimes we fix the value of a variable to an extent and then consider rest as a random variable. For example, we consider minimum value as a fixed value. We know that today there will be evening, right? So how many of you know 100% means for sure that there will be evening after the afternoon? Everybody knows, right? So after the sun, after afternoon means after sunset, there will be evening. But will that evening be chilly evening or warm evening? No, we are not sure 100%, right? So first part is fixed, that there will be evening, but later part is like it will be a warm evening or chill evening. We don't know. So we call it like fixed random variable. And in this case, oops. In this case, if we see, if we consider um, random variable y as any random variable, so we can say that y is average of random variable, then expected mean can be shown as an expected value of y, which we will use a lot from now on. You can also say it as a mean. So y is series of random variable, and expected y is its mean. Mean means average. We will learn later on that what exactly average is. So if y is a random variable, so expected y can be shown as mean or average. You know average, right? You sum all the points and then divide it by the total sample size. It has different, we will use it later on, but it has different properties. So remember, y is a random variable. So the mean of a random variable or mean of any variables, like it has different properties. What are those properties? Let's first talk about those properties in different way. Yeah, so I'm gonna move a little bit on this side, and then so one that's mean if y is a random variable, then expected y is the mean. Means y bar in simple sense. But because it's random, we don't know that series, so we call it expected, what we expect to come. So there are certain rules. One, that expected value of constant is always constant. That is, if we have attached any constant with the random variable, then it can turn out to be, any constant, and we take a mean of any constant. So the mean of a constant will be a constant. Like we have a series of constant which doesn't change, 2, 2, 2, 2, 2, 2, 2. So what's the mean? No matter how many 2's are there, the expected value of constant, so it's constant, right? Constant means same value. So it will be constant because sum of c upon n, 1, 2, 3, 4, 5, 6, 7. So 7 to 14, it is also like 14 by 2, which is again 14 by 7, which is again 2, right? So it's same. That's why we call it that rule number 1 for random variable mean is that its average is constant. Second, we can say that if there is some if there is some times of a constant with the random variable, if some constant is multiplying with the random variable, and we have a series of a random variable, like same constant, 7, 14, 21, right? So, and so on, like 28. So what is this? 7 is constant, and then other one is changing, right? The other one is changing. So this one is changing. So this we can call it variable, but this is a constant. So in that case, expected value of will be, you can take out the c and then expected value of y. So here you can say 7 and then expected value of that random variable, if that random variable is y. So 4, 3, 7, 7, 2, 9, 10, 10 by 4 is like 2.5. It's like whatever the answer is, that was the same. So that's number third property, second property. So third property is that the mean or the expected value of two independent variable will be two different averages, two different means, and two different expectations. For example, expected value of y1 and y2, whereas y1 and y2 are two independent, total independent variable. Sorry, it's time. So it will be expected value of y1 times expected value of y2. So these are the properties of mean, of average. Similarly, we can talk about the properties of variances. We can also have a proof. If you want a proof, there you can take like take like the lecture notes from statistics classmates of yours. It was, I think, lecture 3 or lecture 2 or lecture third lecture or second lecture, where I have explained these concepts in detail. But here I will also give you a little bit of glance. Now, moving towards the variance, we can learn about different properties of variance. So what is variance actually? Variance of y, it means variance means change. That's for sure, we know that. Change from the mean. So variance of y will be how much change, how much y is moving away from its mean. Y bar, that's the variance, right? And the normal way to calculate is upon n plus 1 or n plus 1 or n. Now, if we do it in the same way, we know the variance can be, can I write y minus y bar? Yes, I cannot. I can. Oops, there's so much thing. So can I write this expected value of y? Because we know expected value of y is the mean, is the average. So that can be considered as a variance, expected value of this, because we know expected value of y equal to sum of y upon n, right? So when we put expected and when we open it, it will give us the same way. Why, if it's not random, right? So it's going to give us the same way, because expectation is this, sum upon n. So that's how we can calculate this way. So that's how we can get to variance of y. It can also be denoted as sigma y square. And standard deviation will be the under root of sigma square. I think we have done at in Excel how to calculate variance already. Just a concept here. So there is a property that variance of a constant is always 0. Why? Because it's constant, it's not moving. So if there's a constant 2, 2, what's the change? Change is 0, right? So that's why variance of constant is 0. Third one, so this is easy one, this is easy one, this one you have to, there's also a proof. We are not going into the proof, but we will see that what the proof will give us. And that's if we have a variance of a constant with some variable, random variable. When I say a variable, it's understood that I'm talking about the random variable. It's a c square, means the constant gets the square and then the variance of y, and variance of y is the similar formula which we can put it and we can find out this one. Similarly, continuing the same concept, we can say that if we have two independent variables and they are constant with them, like c1 and dy2, it can give us c square variance of y1 plus d square variance of y2. I didn't do anything, I just extended this to both of them. So that's about the variance, whereas we already learned about covariance. What is covariance? Covariance is a relation between two variables, two independent random variables. So if it's positive, it means if one increases, it can increase in another variable. Let's say car and petrol. So if the petrol prices increase or the gas prices increases, the value of car will also increase, right? It's just an example. So there is a positive covariance between the price of a gas per liter and the price of a car. There are also certain properties. So we can denote covariance of two variables as y1, x, y1, y2. Any variable, because these are random, it can be shown by sigma y1, y2. And it can be given as, because it's an, we know that standard deviation is the root form of a variance. So here there are two variables. So in variance, it's the same variable. So that's why we take it as a square. Y minus expected y, we take square. But here there are two different variables. So we can say y1 minus expected value of y1 times y2 minus expected value of y2. So that's the covariance. That's how you can get covariance. So if you have a series of y1, you can easily calculate the covariance. The covariance of two variables is always 0. Why? Can you tell me? So simple to understand, logical, because these two variables are independent from each other. They are not dependent on each other. They are totally two different variables. So of course their change will be different, right? And if we include constant, so the covariance of constant d1 and e plus fy2, these are two variables. So covariance will be df will get out because it's with the variance, that will be 0, and it will be covariance of y1 y2, which is again 0. So it will be also 0. So when we collect the data shows also a shape, that what kind of a shape it carries, which can be observed by drawing a histogram. How to do that, we will see in 5 minutes. It can be histogram based on the frequency distribution, stem and leaf plot, and this there are different ways to get the depth, but we have to plot it. So let's say this is histogram. Oops. So this is, I'm getting the shape if I draw a curve. So similarly, stem and leaf, this is the different processes. So we have like here numbers. So I can also draw a shape here. So stem and leaf is this form and histogram is on a horizontal form. So let's have a look on this after a 5 to 4 minutes break.